boys and girls, this is Mr. Cook, and today for Chapter 2, Lesson 13, we are going to relate addition and subtraction. So for today, on Thursday, October 29th, 2020, we're going to start with our problem of the day. We're going to draw a diagram to solve this problem. Marcus buys 5 baseball cards each week. Okay, so I know he's buying 5 baseball cards each week. How many cards will Marcus buy in 2 weeks? So I know that I have 5 baseball cards this week, but it says for how many he would buy for 2 weeks. Now be very careful, we're not doing 5 plus 2, because that would mean that on the second week he bought 2 baseball cards, but in the first sentence it says Marcus buys 5 baseball cards each week. So that means if he's buying them in 2 weeks in a row, what number would go right here? If you said 5, you are correct, because if we have 2 weeks, he's buying 5 baseball cards on the first week, 5 baseball cards on the next week. Now we can try to solve this by drawing a picture. Remember, what Mr. Cook says is draw a line down the middle so you can balance one side and the other. So we're going to draw a picture on this side first. So I have 1, 2, 3, 4, 5. And on this side I have 1, 2, 3, 4, and 5. Let's count those all up together, boys and girls. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we know that 5 plus 5 equals 10. So we're going to have 10 baseball cards for my friend Marcus in 2 weeks, which is pretty awesome. All right. Now, boys and girls, this is where it's going to get a little funky. Today, we're going to start talking about addition and subtraction and how they are both related to each other. So let's talk about this group here. Armando has 5 grapes. Savannah has 3 grapes. How many grapes does Savannah and Armando have in all? What we're going to do is we're going to solve this problem together, and then we're going to talk about what it means to make a related subtraction problem by looking at just our addition problem. So let's take a look here. I'm going to use this one as Armando's plate on the left, so he's going to have 5 grapes here. So I have 1, 2, 3, 4, and 5. And on this side, I have 1, 2, and 3 for Savannah. When we add them all up, we have 1, 2, 3, 4, 5, 6, 7, 8 grapes all together. Now, how are we going to make this into a subtraction problem? Now remember, we can only use these 3 numbers down here on the bottom for subtraction. They cannot change. Anytime that you're doing a related addition or subtraction problem, you must use all of the same numbers. So let's take a look. We know that when we do subtraction, we must start with the biggest number. That's the only way this is going to work. So we have to take a look up here on the top part, and we have to see what's our biggest number, because that's the only way we can start with subtraction. We start with the biggest number, and then we take away part of it. We've used our part-whole maps in class, boys and girls. So we know that the whole is going to be right here. That's the number 8. We're going to put 5, and we're going to put 3. Now this is what it looks like with the addition one as well as the subtraction one. But we know that the biggest part that we have is 8. And then up top, if we look at our part-whole map, we're going to just take away one side of it. So let's just say I take away 5. That should mean that I'm left with 3. But before we just move on to the next problem, I want to make sure that we're actually checking our work here. So let's draw it out. I'm going to draw a line down the middle to make sure I have all my stuff on the right side. With subtraction, we always just draw the biggest number, which is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And I know I'm going to be taking away 5 of them. So 8 minus 5, let's take away 5. 1, 2, 3, 4, 5, and then circle your remaining dots right there, boys and girls. And yes, it is. We have 3. So remember, a related addition and subtraction problem must use the same numbers even if they're in a different order. So let's investigate that a little further. What I'm going to do right now is I'm going to place 8 circles on the screen. 2, 3, 4, 5, 6, 7, and 8. Awesome. I'm going to take some away. It's going to be a random number, so let's just start moving here. So 1, 2, 3, 4. Let's just take away 5. Actually, you know what? Let's do 6. So for my subtraction problem up top, I know that I have 8. I minus 6 of them, and what is left is going to be 2. Now, how am I going to make this an addition problem? What if I did this? 8 plus 6 equals 2. I use the same exact numbers, so let's check to see if that's going to work. Alright, I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, and then I have on this side, I only have 1. And hold on one second. This doesn't make any sense. So remember, when we do our related problems, you must use the same numbers, but you got to think about how these are going to work. So with subtraction, the biggest number is always at the beginning of our sentence. And at the addition problem, our biggest number is going to be our product, which is the end or our sum. So we have to think of this like here. Now, boys and girls, when we do subtraction, like I just said, biggest number goes first. Addition, biggest number goes at the end. So that means I can put these two numbers wherever I want to make this one work. So if I did 6 over here plus 2, let's check to see if that works. 1, 2, 3, 4, 5, 6, and then 1 and 2. So if I count them all up together, I've got 1, 2, 3, 4, 5, 6, 7, and 8. That does equal 8, so that is a related equation because they use the same exact numbers, and this one works. So remember, related facts have the same exact numbers in all of them. We're almost called fact families, is what I'm going to be introducing to you guys right now. Fact families are using 3 numbers to create 4 problems: 2 addition and 2 subtraction. So the one that we're missing actually right here is going to be 2 plus 5 equals 7. What I like to call these are called flip-flops. Because all you're doing is flip-flopping the numbers. So for addition, you flip-flop the 2 of them right there. For subtraction, it's going to be a little bit of the opposite. So if I have 7 minus 2 equals 5, I'm still going to start with the biggest number, but all I'm doing is flip-flopping the end numbers right there to make a flip-flop on that side. So let's do this using our part-part whole maps. Now, we always have the whole here. We have our parts and our part. So what I'm going to be talking about right now is when you have an addition problem, remember, does that go at the beginning or the end as your biggest number? So whenever we have addition, we take 2 parts to make a whole. It's part, part, whole. So let's do that on the bottom here. So I have part plus part equals the whole. On the bottom with subtraction, we do a whole minus part equals part. So that means I can start with the whole. Remember, biggest number with subtraction first, and I can pick any part that I want. So I could do, let's say, 6 equals 3. If you were using a mat at school, it might look like this, where you would have 3 pieces right here. You'd have 6 pieces on this side, and then what you would do is you would drag them all down to the bottom to make that whole piece right there. Or you would start with the hole on the bottom and move pieces up to here and some of them up to here to make your problem work like that. Let's do one more. I know that I have my part, part, whole. So part on the top, hole on the bottom. So with addition, I take the 2 parts and I put them together. So I've got 2 plus 4 equals 6. I know that because I've already solved my problem on this side over here. Next part that I have, boys and girls, is going to be the whole minus part minus part. So what that's going to look like is taking the biggest number for the whole, which is 6, subtracting part of it, let's just take away 2, and that would equal 4 right there. So challenge for you guys right now, take a look at these problems and see if you can find out the other 2 equations. If I did 2 plus 4 equals 6, what do you think my flip-flop of that would be? If you said 4 plus 2, that is going to be your flip-flop. Let's think about this. 6 minus 2 equals 4. What's going to be your flip-flop for this one? Is it going to be 2 minus 6 equals 4? Well, if I did that, if I did 2, I can't take away 6. That one's not going to work. But I remember what Mr. Cook said. You don't flip-flop the front 2 when you do subtraction. You flip-flop the back 2 when you do subtraction. So that means I have to do 6 minus 4 equals 2 on that one. Alright, so boys and girls, this is what you're going to be doing in class today. If you're at home doing your learning, you can get going on all your pages. If you're in school, this is what you're going to do. You're going to take your spinner that we all cut out for you. Using your paper clip, you're going to spin it twice. So let's pretend that I use my spinner. I spin, I land on the number 4. So I'm going to put that right here. Next step, I'm going to put that up top. We're going to spin again. Let's say I spin, land on the number 6. I'm going to put that as my part up top as well. And right there. And what I want to do is I want to try to figure out what this is going to be for the hole on the bottom. So I have 4 right here. 1, 2, 3, 4, and then 6 right here. 1, 2, 3, 4, 5, and 6. If I count them all together, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So my hole is going to be 10. What would my subtraction problem be here? So remember, when we do addition, it's part plus part equals whole. Subtraction is whole minus part equals the part. So my hole on this one is going to be 10. I'm going to take away a part here, which let's just say I take away 4. You can do whatever one that you want. And that equals 6 here. When you guys do relating addition and subtraction, you cannot use any other number besides the ones that are given. So you can't say 10 minus 6 equals 5 because that is nowhere up in here. You can only use the numbers 4, 6, and 10. All right, boys and girls, good luck and have fun.